magnetism, guys. It's about pendulums. Hey, we're back.
Where'd it go?
And we're going to talk about the physics of pendulums. I just love pendulums. They do so many cool things.
All right, let's get into it.
Let's get into some history about the pendulums real quick. This guy, Galileo Galilei, born in Pisa in Italy, was one of the guys who started to study the movement of pendulums. He was an astronomer and a mathematician. He also added to the theory of solar centrism, which is the theory that the Earth goes around the sun rather than the sun going around the Earth. But he was sitting in church one day and watching the chandeliers, which is a big fancy lamp, swing back and forth, and he noticed that the lamp swinging was the exact same time from one side to the other, no matter what happened. It always swung the same amount. And he was really curious about that, and after church, went home to do some experiments on those things. And we're gonna do the exact same experiments today.
Before we talk about all the cool things that pendulums can do, we have to talk about the parts of a pendulum. A pendulum has a part that it swings from, and that is its pivot point. And then a part that drops down, that's called the length, and the weight at the bottom is called a bob. Well, Robert, if you don't know him too well, but no, I'm just kidding. It's called a bob. Now, there are three important variables to discuss when talking about a pendulum. The first variable is how long is the length. That may or may not change how it swings. The second is how much does the bob weigh? And the third is how far do you displace the pendulum when you pull it to the side before releasing it. Only one of those things is going to have an effect on how many times the pendulum can swing back and forth in 1 second. A pendulum swinging that way and then that way is called a cycle. And how many cycles it can do per second is measured in hertz. All right, so we're going to do a quick experiment with the three variables and see which one has an effect on how many cycles per second we get out of a pendulum swing. The three variables again are displacement, how far we pull it to the side, the weight of the bob, and the length of the pendulum. Mr. Kyle, can you do some timing for us here?
I'll time.
All right. First experiment is we are going to pull it to 90 degrees. Now when we count cycles, we don't count 1, 2, 3. We need a complete swing, so we count 1, 2, 3. Are you ready to count with me at home? All right, let's get started. We're going to start by displacing to 90 degrees. Mr. Kyle, are you ready to roll?
I'm ready to time.
On your mark, get set, go. 1,
1, 2, 3, 4, 5, 6, 7, 8, 9, stop.
So we got, I almost counted the cycles incorrectly at the beginning there. It's easy to do, but we got 9 cycles out of 90 degrees. Now let's try 45 degrees. Are you ready? Mark, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 6.
Oh, right about 10.
Right about 10. Okay. And now let's try 30 degrees. Are you ready?
Yep.
1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11,
Stop.
10. Okay. All right. Maybe a little bit different in here, but mostly right at 9 or 10. Okay, now let's change the weight of our bob. And we're going to do that by adding a few pieces here. All right, so we've 2 extra ball bearings and a nut and a bolt. And we are going to displace it to 45. And 45 degrees, when it was light, we got 10. So we can just transfer that on down here. And again, we're going to displace to 45. Mr. Kyle, are you ready?
Ready.
Mark, get set. 1,
1,
2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we're right at 10 when we tripled the weight of the bob. Now, we have displaced to 45 degrees with this length, with this weight, and we've still gotten 10. So if we transfer this 10 down here, this is our long bob. Now I'm going to change this to a short bob and a short length and see if that gives us any changes. Okay, we took off the long pendulum length and we changed it to short, and we've got 1 ball bearing in there, so we're about the same as the light weight. And we're going to displace it to 45 degrees again to control the rest of our variables. Are you ready to roll?
Ready to roll.
All right. Count with us, guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
15.
Wow, 14.
That 14, that's a lot more than 10 and 9.
That is. All right, so we're within 1 cycle in all of the other variable conditions. But when we changed the length, it changed how many cycles we got per second. So the only variable that matters in pendulum swing is the length. And that's kind of interesting, because I noted when my kids were little and I would get on the swings with them, I weigh 150 pounds and they weigh less than 50 pounds. And if we were in swings that were the exact same length, we could stay swinging together, which is called swinging in phase. But if one of us had a shorter or longer swing, we would get swinging opposite of one another and couldn't even hold a pattern, and that's called out of phase.
All right, guys, now that we know more about how pendulums move, they're very predictable, right? If I just place it over to this side and let it swing, which direction is it going to go? That's right, this way. And then if I let it swing from this direction, what's it going to do next? That's right, it's going to move the other way. It's very easy to predict what a pendulum is going to do. This is known as simple harmonic motion. But there is another thing called a double pendulum, where we add a second pivot point at the bob, a second length after it, and then a second bob on the end of that. This double pendulum, because we double the variables that we have, it becomes very difficult to predict. Let's make one and see how it goes. Here we have our double pendulum. And our double pendulum can do some crazy stuff. We know that a single pendulum swings very simply. But right now at home, I want you guys to make a hypothesis about how a double pendulum will swing if I just place it. Is it going to move like this? Is it going to zigzag back and forth? Or is it going to be way more unpredictable? Let's find out. Here we go. Wow, that's pretty crazy. I like it when it spins all the way around. Look at that. I wouldn't even know how to count the cycles on something this crazy.
Ah!
So having just a tiny change in how we displace this double pendulum, leading to big changes in how it acts, is a mathematical term we call chaos. And I'm sure you guys see, lots of chaos. I'm sure you guys have heard people say this word chaos before, and they're like, oh, your room is chaos. When you and your friends get together, it's pure chaos. But chaos doesn't just mean crazy. It's a mathematical term that means very difficult to predict. Remember, a single pendulum, easy to predict. And then a double pendulum is difficult to predict or chaotic. Watch this video.